2, 1, 0.
In May 2022, NASA launched a novel CubeSat into low Earth orbit. That CubeSat was the Pathfinder Technology Demonstrator-3, carrying the TeraByte InfraRed Delivery payload, also known as TBIRD. TBIRD was designed and built by MIT Lincoln Laboratory to deliver large volumes of data from LEO to ground. In our most successful experiment to date, we have successfully downlinked 5 terabytes of data from low Earth orbit to ground in just 5 minutes. This was done at a record-breaking 200 gigabits per second. This is the equivalent of transferring a single 50 gigabyte Blu-ray disc every 2 seconds for 5 minutes straight.
Historically, communication in space is enabled with radio or RF. During the iconic 1960s missions on the Apollo program, radio was used to carry Neil Armstrong's Giant Leap for Mankind broadcast to Earth. And since then, radio is still used for communication with the International Space Station and the James Webb Space Telescope. However, radio is unfortunately slow, relatively speaking. That speed is causing challenges for the ever-increasing volume of data that has to be transferred from new ongoing missions in space.
MIT Lincoln Laboratory has been leading the development of free space optical communications for decades now. In 2013, we did the first demonstration of laser communications from the Moon to Earth, demonstrating 622 megabits per second.
Operating in low Earth orbit involves different challenges than operating in geosynchronous or in lunar orbit. A LEO satellite is only over its ground terminal for about 5 to 6 minutes, providing very little time for data transmission. However, if receiving data in real time isn't critical, we can use a buffer and burst technique, where we store up data and then burst it down to Earth while we're over the ground station. Another challenge is that laser signals degrade as they travel through the atmosphere. To address this, we employ a custom automatic repeat request, or ARQ protocol, to provide error-free transmission. TBIRD has a 200 gigabit per second downlink, but we also have a 2 kilobit per second uplink that provides information from the ground station to tell the satellite to retransmit any data that have been missed the first time.
Even if the ARQ parameters are chosen perfectly, communication can't happen unless there's a clear line of sight between the 2 laser communication terminals with nothing blocking the beam. And a challenge of laser communication as compared to radio frequencies is that laser beams are very narrow, which means that we have to point them precisely to be able to do communication between 2 terminals. And on other programs at Lincoln, we've done this with things such as gimbals or fast steering mirrors, but TBIRD is unique because we don't have any actuators on the payload. So we do our pointing just by steering the body, using a signal that we're receiving from the ground to do the pointing.
Compared to existing radio satellites and even other lasercom terminals, TBIRD is tiny, just 3U. Packed inside the payload are 2 modems, 2 optical telescopes, 4 SSDs, an optical amplifier, and all of the electronics needed to control the components as well as the data transmission. To get everything to fit, TBIRD uses modern commercial technology. Fiber telecommunications hardware has advanced significantly in the past decade, driven mostly by the needs of data centers and long-haul communication. Each new generation of hardware is smaller, has a higher data rate, and is more power efficient. However, the commercial terrestrial lasercom equipment we're using was not designed to handle the launch into space or the harsh environment once we reach low Earth orbit. To make sure it would all work, we performed vibration testing and thermal vacuum testing on each component, as well as the system as a whole.
For the past year, since the launch of the CubeSat, we've been conducting a campaign of experiments, and this has been in partnership with Terran Orbital on the spacecraft side and NASA's Jet Propulsion Laboratory on the ground side. The ground station is located in Southern California at NASA JPL's Table Mountain facility. To support each pass where the satellite comes in contact with the ground station, there's a team of operators, and they're spread over these 3 different organizations, and they coordinate activities to make each pass a success, things like spacecraft sequencing, controlling the ground telescope, and monitoring laser transmission. There's been a lot of hard work and technical problems to solve along the way, from concept and design to build to this flight demo, but it's really paid off with some exciting results. We've been able to demonstrate extremely precise beam pointing and downlink terabytes of data per contact, all from a tiny CubeSat.
TBIRD has shown an incredible leap forward in the amount of data that can be transferred from space to ground. So what's next? We're looking to transfer this technology to missions such as science missions that can use this capability to demonstrate groundbreaking new science that would not have been possible before.
In the time it took for you to watch this video, TBIRD downloaded 5 terabytes of data from LEO to ground. Thanks for watching!